Okay? Only difference, change the sign. So here we go. We're going to do a little practice here. I gave you a little easy problem at the bottom. So we're still doing the opposite of the order of operations, ladies and gentlemen. We're going to subtract 5 for both sides. So negative 2x is greater than or equal to 4. And then we shall divide both sides by negative 2. So negative 2x divided by negative 2, since they have a common factor, we can reduce them. We're left with x. 4 divided by negative 2 would give me negative 2. But ladies and gentlemen, both sides of the inequality have been divided by a negative number. Therefore, we must change the sign of the inequality to its opposite. So it's x is less than or equal to negative 2. Questions so far? All right, so ladies and gentlemen, the question is like, how do we graph this? And I know you guys know how to graph this, but once again, I'm going to give you some insight as to understanding how to graph it. First of all, I do not want your graph to look like this. Okay? It's messy. It's much too much time and effort. So, your graphs, ladies and gentlemen, shall contain the important points. The important point is negative 2. Why is it important? Because this is called your boundary point. It bounders the solutions from the non-solutions. It's a fence, if you will. On one side are the solutions, the other side the non-solutions. Now the question becomes, yeah, but what about the fence? Is the boundary point a solution or not? Yes, it is. Yes, ladies and gentlemen, negative 2 is in fact less than or equal to negative 2. That is a true statement. So to show that the boundary point is a solution, we would put a closed circle. And if it was not a solution, it would be an open circle, signifying that everything up to but not including that point was a solution. Now, either to the left or to the right are all the solutions. Where are the values that are less than negative 2? They are to the left, like negative 4. Negative 4 is less than negative 2. It's a solution. So all these points in this direction, ladies and gentlemen, are solutions. So we draw this array that contains an infinite number of points. All we're doing is connecting all the points that are solutions. Nothing on this side of the line, like if we pick the number 5, 5 is less than negative 2, doesn't make it a solution. Therefore, we are not going in that direction. So far, so good. All this is review. You've seen it before, I know. Now, the last thing I need to talk to you guys about is what we call interval notation. And the reason we have interval notation, ladies and gentlemen, is because this is how they're going to show you solutions as you move forward. On the ACT and in your higher level math classes, they do not write this, and they sure as heck don't graph it. So you have to write your answers in interval notation. Interval notation, ladies and gentlemen, starts with the least value, the least valued solution, comma, the greatest value solution. And that's how we write it. So ladies and gentlemen, in the case that we have right here, what is the least? Now let's do the greatest. What is the greatest value of x that makes this equation a true statement?
Negative 2.
Thank you very much. Negative 2, it goes on the right. What is the smallest value that makes this a true statement? Negative infinity is correct. Ladies and gentlemen, please understand, infinity is not a number, it's an idea, and it means something goes on forever. So that's why we write it. Now, the question becomes, are these the least value and the greatest value, are they solutions? Well, is -2 a solution? Yes. Then we symbolize it by drawing a bracket. The bracket coincides with the closed circle. They mean the same thing. Now, is -infinity a solution? No, because -infinity isn't a number. Anytime you use infinity or -infinity, parenthesis. So, ladies and gentlemen, when you are using an open circle, you will use parentheses. When you have a closed circle, you'll use a bracket. They mean the same thing. It's the same concept, same idea. Okay, so let's go to the next page. Ladies and gentlemen, that's all I got. So here we go, ladies and gentlemen. My little notes here telling you what's going on. If you graph an inequality, the closed circle means that the points are included, meaning they make the statement true. We use a closed circle. If you use an open circle, it means that it's everything up to but not including that point. It's still a boundary point. It's just not included in the solution. And you can see when writing in the interval notation, ladies and gentlemen, the brackets mean the same thing. If it is included, you're going to use brackets, same as a closed circle. If it's everything up to but not including, you use parentheses. Now, I know I'm going quick here, so if you don't get it, yell at me. What I would like you to do, ladies and gentlemen, x is greater than 4. Please graph that and write it in interval notation. You have 60 seconds, begin. All right, ladies and gentlemen, there is my answer. Questions? Your question should start with, where did you get, or why do you have? And ladies and gentlemen, if you don't want to answer it out loud, you have that little chat privately thing. You can ask without identifying yourself, which is a good thing. No problems. Great. Let's do the next one, ladies and gentlemen. Please show me on the number line all the numbers that are greater than -3 and yet still less than 8. And see if you could put it in interval notation, please. Boom! There you go. Questions, problems? Okay, ladies and gentlemen, last one. Greater than or equal to 5, less than or equal to 12. All right, ladies and gentlemen, I got a 5 and a 12. Those are my boundary points. Closed circles because they're both included. Everything in between, 5 to 12. Questions, problems? Now this is pretty easy, Richard. Okay,